Welcome, sports fans, to iChem and Unit 10. Yes, we are jumping into Unit 10, and that is all about heat. Ooh, I like heat, and temperature and kinetics. So let us get started here. Consider heat and temperature. Are these the same thing? So is heat is heat synonymous for temperature? Is temperature the same thing as heat? Well, let's find out. So let's start our concept map with heat and temperature. Got it? And let's go over here and let's start with temp because we know something about temp already, don't we? Yes. When we discussed our gases, we said, hey, temperature is a measure of the average kinetic energy of a set of particles. Cool, right? So we said average kinetic energy is a reflection or is a measurement, or temperature is a measurement of average kinetic energy. And at that time we said, hey, average kinetic energy is equal to what? 1/2 mv squared, where v is the mass and v is the velocity of the particles. Good. So that is temperature. And average kinetic energy, we say, is what? The energy of motion. You'll remember that from your physics class, or you'll learn it soon in your physics class. Good. So that's what temp is. So when temp is high, what does that mean? When I have a high temp, that means what? I have high average kinetic energy, meaning my particles have a high velocity. Good. Now, how is that different from heat? Well, heat is a completely different concept. Heat is really a form of energy, or really the transfer of energy, between two bodies. Between two bodies due to a difference in temp. Aha. Okay, so heat is energy, and it is a transfer of energy, and that transfer occurs because things are at different temperatures. Okay, cool. Now, another way to really think of this is that heat is energy used. Heat is energy used to increase the temp of a body or set of particles. Got it? Now, it could be the opposite too. Heat can be the energy lost. So heat can also be the energy lost to decrease the temp of a body. So when something gains heat, temp increases. When something loses heat, temp drops. This is the best definition. This is the one I want you to know. Now, there's one other thing we ought to know about heat, and that is heat always flows. Heat, we say, flows. I don't know why we say flows. Heat goes, heat flows, heat transfers from hot bodies, or right, I like hot bodies, to cold bodies. Yikes. Good. So heat always goes from hot to cold. You never have heat going from cold to hot. Okay, good. So I think we have discussed our different things here. Are these the same thing? No. Heat is the transfer of energy caused by a difference in temp, right? That's what heat is, zoink. And what is temp? That is a measure of average kinetic energy of my particles. Okay, good, cool. We know the difference now between heat and temp. Moving forward, considered changes in temp of 1 degree Celsius and 1 degree Kelvin. Which is bigger? I'm not sure I can answer that just yet. Let's go back and let's add some more notes on our temperature side. You thought, oh, we know everything about temperature. Well, we did learn some things about temperature. We said there are 2 scales here in temp. Let's come off here. Temp, zoink. Let's come down here and let's talk about the 2 scales. Scales. The 2 temp scales, right? We want to talk about Celsius, right? And we want to talk about Kelvin, right? Notice with Kelvin, we don't use the little degree sign. We just say Kelvin. Zoink. Good. Now, let's talk about the basis for each of these. What is Celsius based on? Celsius is based on the freezing point and the boiling point of water. That is the basis of Celsius. So Celsius begins at 0, or let us say that 0 Celsius is the freezing point, and 100 Celsius is 100 Celsius is the boiling point. So that is the basis of Celsius. Water, essentially, the freezing and boiling point of water is Celsius. Kelvin, on the other hand, the basis of Kelvin is the motion of particles. Motion of particles. And what do I mean by that? Well, when I have 0 Kelvin, particles cease motion. Cease movement. They no longer have, the velocity of the particles is 0 at 0 Kelvin. And what do we call this? 0 Kelvin, and it's called absolute 0. So at absolute 0, my average kinetic energy, my average kinetic energy is 0. And my particles cease all motion. They no longer move. And so the basis of Kelvin is absolute 0, or you could say the motion of particles. So they really have 2 different bases. And so let's add this, right? We have the freezing point. Oh, what's the relationship between these? What's the relationship? We've learned this before, but just to remind each other, what is it? Kelvin is equal to degrees Celsius plus 273.15. And remember, Kelvin can never be less than 0. Yoink, no, it can never be less than 0. The lowest Kelvin can be is what? 0. Good. So when we look at the freezing point of water, Celsius is 0 degrees Celsius, so add 273, and it's 273.15 Kelvin. What is the boiling point of water? 100 Celsius, and what? 373 Kelvin. Now, just for the heck of it, let's take a look at the difference. What is the change in temp between freezing point of water and the boiling point of water in Celsius? Okay, the difference in temp is 100 minus 0, so the delta T here is equal to what? 100 degrees Celsius. Good. What's the delta T over here? Well, if I look for the difference, I'm going to take 373 minus 273, and I get 100 Kelvin. Huh. Wait a minute. So the delta T of Kelvin is 100 between freezing point and boiling point of water, and the delta T of Celsius is 100. So what does that tell me? That the delta T in Celsius is equal to the delta T in Kelvin. Aha, so the delta T's, as long as I'm looking at the change in temperatures, the change in temperature in Celsius and the change in temperature in Kelvin are the same. And that means, what can we conclude from this? 1 degree Celsius is equal to, excuse me, I have to be careful how I say this, the size of a degree in Celsius equals the size in Kelvin. That means a change. They're both the same increment. When one goes up 1 degree, the other goes up. When one goes up when I have an increase in 1 degree Celsius, that is equal to an increase of 1 Kelvin. Got it? We're not saying 1 Kelvin equals 1 Celsius. We're saying that the change is equal. Egads. Okay, good. So back to this. Which is bigger? Well, the answer is neither. We're looking at the change in temp. That means they are the same. A change of temperature of 1 degree Celsius is equal to a change in temperature of 1 Kelvin. But remember, that's only when I'm talking about a change in temperature. Cool? Great. Okay, let us move on. I have a 10-gram block of iron initially at 285 Kelvin. What is the initial temp in Celsius? Okay, we can handle that. All right, what am I going to do? I'm going to take 285. I'm going to say that Kelvin is equal to degrees Celsius plus 273.15. So I'm going to say that 285 is equal to Celsius plus 273.15. And so when Celsius is going to be equal to what? 12. And if I just look at sig figs, 12 Kelvin. Got it? Cool. Well, not 12. I don't think it's 12 Kelvin. I think it's 12 degrees Celsius. Great. So 285 Kelvin is equal to 12 degrees Celsius. Okay. How much heat must be added to the iron to raise its temperature to 397 Kelvin? The specific heat? What? Specific heat of iron is this number. Guess. Let's see how much time we have. Yeah, I guess we can do this. Let's go ahead and do it. All right. We need some notes. So let's go over here. We're talking about, let's go here. We're talking about heat and stuff. And we want to talk now about really, whoops. Oh, look at this thing. Okay, we want to talk about heat transfer a little bit. Heat transfer. Heat transfer meaning when heat is transferred from one body to another, right? Cool. Or when energy is transferred, we call that kind of heat transfer. We're really talking about raising temperature by the transfer of heat. Good. So we have one big equation, the big equation. And the big equation is Q. Oops, what is Q? Q, ladies and gentlemen, I should have added this up here. Q, heat is known as Q. There we go. Woo! So Q, heat, is equal to M C sub P delta T. Okay, what does that mean? That means the heat that is transferred in some kind of process, is equal to the mass of the material, mass of the substance, times the specific heat of the substance, so let's call that substance instead of material, times the change in temperature of the substance. Okay? So this says heat is equal to mass times specific heat times delta T. And there's a concept. We understand mass, we understand delta T, but what's this specific heat? Well, let me give you a definition of specific heat. Specific heat is the amount of heat required to raise the temp of 1 gram of a substance, 1 Kelvin, or 1 degree Celsius, right? Because when we're talking about change, they're the same. Cool? Is the amount of heat required to raise the temp of 1 gram of a substance, 1 Celsius. Now, usually we're going to see this as a little c sub p. Sometimes you might see it as an S, okay? So those are kind of the abbreviations. And then the units for specific heat are going to be joules per gram Kelvin or joules per gram degrees Celsius, which brings us, what's this joule thing? Yipes, got to go back up to heat. If we go up to heat, we want to talk about what are the units of heat. Units of heat are the joule, known as a J. Got it? So the units of heat are a joule. The abbreviation of heat is Q. Cool. Sorry about that. Excellent. Okay, so there we go. My heat transfer, the amount of heat transferred is equal to mass times my C sub P times my delta T. Now, one other thing about specific heat. Specific heat, right? The size of it. If I have a big number, a big specific heat, what does that imply? Well, we said it's the amount of, think about this, the amount of heat required to raise the temp 1 gram, the temp of 1 gram of substance 1 degree. So if this is a big number, that means it takes, if I have a big specific heat, that means it takes a lot of heat to raise its temp. Good. So think about, putting a piece of silver in boiling water. Okay, so here we have some boiling water. Okay, boiling water. That means it's 100 degrees Celsius, right? And I have a wooden spoon. Here's wooden. And here's silver, right? Silver. Now, which of these do you want to grab? Well, if I'm going to stir this, which of these am I going to grab? I'm going to grab the wooden spoon. Why? Because it's not as hot. It doesn't get as hot in the same amount of time. What does that mean? Does it take a lot of heat to make that change or a little heat? Well, if this is at a lower temperature, let's say these are both in here for 5 minutes, and this guy comes up to 90 degrees and this guy comes up to 60 degrees. Well, which one required less heat to raise its temperature? Well, the silver required less heat. That means the silver has a lower specific heat, right? Because it takes less heat to cause the temperature to rise. Lower specific heat. This guy takes a lot more heat to raise its temperature, so it has a higher specific heat. Okay, just kind of to give you something to chew on there. All right, here we go. So how much heat must be added to the iron? Okay, here we go. What are we going to do? Q equals mc sub p delta T. What is my M? My M is, I have 10.0 grams. What's my C sub P? C sub P, C sub P, there it is, 0.449 joules per gram Kelvin. And what's my delta T? Well, how much heat must be added to the iron to raise its temperature? So where do I start? I start at 285, so that's going to be my T initial, and I end at T final, and my delta T is always going to be what? T final minus T initial. So delta T is T final minus T initial, 397 minus 285K, right? All right, so let's grab the mighty calculator. And what does my TI-30XA say? I'm going to take 397 minus 285 equals, woohoo, times 0.449 times 10. And my answer is 502.88. How many sig figs? It looks to me like I can get 3 sig figs out of this. So this would be 503 what? Well, my grams cancel, my Kelvin cancels, and I'm left with joules. There we go. 503 joules. So how much heat must be added? Well, 503 joules must be added. Okay, you guys do this one and bring me back when you're ready. Great. Okay, we're going to do what? Q equals M C sub P delta T. So what's my Q? I don't know what my Q is. What's my M? My M is 352 grams. What is my C sub P? 4.18 joules per gram Kelvin. And what is my change in temperature? Okay, how much heat is needed to raise its temperature to? Where do I start? I start here. That's TI. That's TF. Delta T is equal to TF minus TI. Now be careful. Delta T doesn't always have to be positive. It's always going to be TF minus TI, but sometimes it's going to be negative. Be careful there. In this case, it's going to be 325 minus 298. And what do I get out of this? Let's see. It's 325 minus 298, and I get 27. That's a 27 there. Okay, so 27 times 4.18 times 352, and my answer is 39726. How many sig figs? I have 3 here, but I only have 2 sig figs there. So I only have 2 sig figs in my answer. So that means I have to round these guys, and that becomes 40000. Ooh, how do I get 2 sig figs out of that? I have to put it into scientific notation, right? Let's see, 1, 2, 3, 4. So it's 4.0 times 10 to the 4th what? Grams cancel, Kelvin cancels. Oops, should have wrote Kelvin there. And I end up with joules. No. 4.0 times 10 to the 4th joules. What is the final temp in Celsius? Okay, the final temp was 325 K, and we said what? K is equal to degrees Celsius plus 273.15. So that means 325 equals degrees Celsius plus 273. And so my degrees Celsius is equal to 325 minus 273. Yahoo! Mountain Dew, 52 degrees Celsius. Why did I drop the 0.15? Because of sig figs. All right. Degrees Celsius equal 52. All right, let us stop there. Next time we will do another question with this, and then we'll move on to heating curves. Ciao, belle.